There we are. So the objective for today's class is to be able to learn multiple, uh, uh, to be able to do structured programming, where our program will be split in multiple files, multiple functions, and multiple functions will be in different files. Okay. Uh, we have to start. We have to develop this habit to do programming like this only. We will take up an example. I'll take up a very simple example initially, where we will try to take an array and display the array. That's it. Using modular programming means program will be split in functions and functions will be in separate files. Just input an array and display the array. That's it. And when we use array, when we do this, we will be using only pointer to arrays. So I have told this to you earlier how to do this, but we have I think we have done it in using ordinary arrays, not with pointer to arrays, isn't it? From today, in your rest of life, you will never declare an array. You will always use pointer to array. The reason is, when you declare the array in the beginning, you have to specify the size of the array statically, and the size of the array is fixed from the beginning till the end of the program. So array is using array means wasting memory. If you take the size of array too small, then you will lose your data. If you take the array of size bigger, then you will waste memory, isn't it? So in both ways, it is not a good idea to use statically allocated arrays. We must use pointer to arrays and allocate memory for arrays dynamically. Excuse me, as and when required. Okay. So yes, it is primarily applicable in embedded systems only, and the reason is all the embedded devices that you work with are strictly constrained with respect to available memory. You can't afford to waste memory on any kind of devices, isn't it? So we will start programming, and what we understand is we'll have a main function, then we'll have a main menu function, then we'll have two another functions, one that will create the array and another that will display the array. Okay, so just watch. I'm going to do this programming in front of you. If you feel something you're not able to understand or you have some doubts, just ping me immediately. So very first file we create our headers, in which we'll create all the headers. Are you using Vim Editor for the first time, or you are familiar with Vim Editor prior to this training started? Okay, nice. One thing I'll tell you, when you start using Vim Editor, then you go to this file. You go to etc/etc and list. Here you will find a file called vimrc. There you see vimrc. This is the Vim configuration file, Vim editor configuration file. You go to, don't write, I'll give you everything in notes. You just see and watch, trust your mind and not your pen. You go to the bottom of this file and write a line called set number. When you put set number, then you will always have the line numbers displayed in your program. So the file is found /etc/Vim configuration file is found at /etc/vimrc. So Vim configuration file. Is at /etc/vimrc. Okay, here add a line to the end of this script. You add set number. Okay, fine. Then you'll have your Vim configured. I'll tell you so many other configurations also about Vim as and when we proceed. So this is going to be our header file. I have kept only one file right now. Then you will create a declarations.h file in which you will keep your function prototypes. Okay. So we know that we are going to keep a function called main menu. You don't know what is going to be the return type. Initially you would not know. You keep it int by default. You don't know what are going to be the arguments initially, so you keep it empty. Another function you're going to write is get array. Another function, no, let's not use main menu right now, only get array, and another is put display array. Display array. These are the two functions you're going to write. Save it. Go to another tab where you start your main.c. See, the name of the file should be same as that of the name of the function. It is not a rule. It is just a good programming practice. So both the header files that you have created just now, you bring in these files. Okay. Include these files and start your main function. One habit we will develop right from the beginning is to print the function name when the function starts. This will aid us initially while we learn to understand and debug our programs, to understand where the control is right now. Underscore underscore func underscore underscore is a macro which returns the current function name. We'll write these two statements all the time, begin statement and end statement. Inside this, now what we have to do is we have to have an array. So always remember to declare your variables and the pointers at the beginning of the function before you use your first library probe function. So I'm going to create an integer pointer called array, and now I'm going to use this get array function to create array. Call this function get array. The function is called. Let's see what this function do and how it works. You come in get array and this function name, change the function name get array. Here also you declare a pointer called ptr. Okay, and you actually start allocating space for this array now. ptr. You don't know what is the size of array. Okay, so you can enter here, enter and give here array size, enter array size, and you can enter size as an integer value, store in some variable, say s for size. Now what happened is, see, s is a local variable, so size will be known in this function, but the size will not be known outside of this function in another function like main. Okay, so it will cause problems. I will resolve this problem later on. Okay, right now we have size, so we'll allocate space using malloc. You are familiar with malloc? Yes, no? Size of integer. How many integers? S number of integers. Memory is allocated. When the memory is allocated, you typecast it. You are familiar with the concept of typecasting? Yes, no? Okay, so we have typecasted to integer pointer. One rule I'll tell you: the data type in which you are typecasting should be same as the data type of the pointer. The data type of the pointer was int star, so therefore I typecasted in int star. There is a probability of 0.01 actually, where the allocation of the pointer memory may fail. If the memory allocation fails, then you print the error generated from the previous system call and call the exit function. exit function is the function that we will write. Okay, so you have to give the prototype for this exit function. Int exit function. The prototype for exit function would be like this, that when you're going to exit your program, you have to tell the exit function that you are going to exit with failure or success. I say that we are going to exit with failure, so we have to implement exit function first. Let's implement exit function. Okay, so we are in third function. First was the main. From main we went to get array, and from get array we went to exit function. Why I am showing you like this is because this is the way that you will go through the program development. You will not have the complete plan in your mind right in the beginning, but you should have a good starting point at least. The moment you connect, you go to the first dot, you see the next dot. The moment you take one step, you realize what could be the next step. Okay, like we never planned that we are going to write exit function. Suddenly we realized that okay, exit function is needed, and we have to tell it that we are going to exit with the success status or failure status. So it's a realization. That's why it is not called program writing, it is called program development, because the idea is developed, and the program is evolved, not written. Okay, so you see here when I call this exit function, I pass this string as an argument. So this string failure will be captured here in a character pointer, status, failure or success. So suddenly we realized, okay, exit function is going to take a char star as an argument. So go to your prototype, excuse me, and modify the prototype, say that you need a char star. Okay, now in this get array function, in this exit function, you have to exit either with success or with failure. So exit will be done using the exit call. But before you give the exit call, you have to check the status. That what do? Do you exit with success or failure? So check will be done like this. If strncmp. strncmp is string compare function. The n in between here tells compare n number of characters. So we have supplied status. I'm going to compare status with failure, failure, 7 characters. So I say that 7 characters of these two strings, this string and this string. N means 7 number of characters. 7 characters of both the strings will be compared. If the difference is 0, that means you have passed failure as a status. So you exit with exit underscore failure. If in case 2yy p, else if the string compare status was success, then you exit with success status. Okay, now we have used strncmp. For strncmp we have used exit system call. For exit system call we need stdlib, and for string compare we need string.h. If in case sometimes you feel that you're not able to understand, you don't know that which system call or which library function needs which header file, so it's very easy for you to check that. Use info pages. Okay, strncmp, enter. Now info pages are used to know about the C libraries, whereas the man is used to check the Linux commands. So you go down in this, you'll see strncmp somewhere. You have strcmp here. There it is, strncmp. Okay, this is the prototype. First string and the second string and the number of characters to compare. What are the header files that will be given in the beginning of all the string functions? There it is, string.h. Okay, so like this you will not need to ask anybody. You can always use info pages. It is always there in the Linux operating system. Okay, so the exit function is done. Close it. Come back to your get array function. Now you have allocated space for the array. Okay, after allocating space for the array, now you have to insert elements in this. So yy, copy the line, p for paste the line, enter array elements. So all the array elements will be entered in the for loop. It's a less than s, I plus plus. Okay, now scanf and store the values in the integer values in the array which are pointed to by ptr. ptr plus I. ptr plus I gives you the address of the particular array element where you have to store the values. After that, this ptr which is created here is a local variable, so it will get destroyed, isn't it? So before it gets destroyed, you must return it like this. Here we'll try to simulate this program here. So what you have done is you created the main function. Inside main function you created star array, which is a pointer. See this star array. Then from here you call the get array function. You called get array function, and the control jumps to the get array function. The get array function starts to execute. In the get array function you have declared ptr. Then you allocated memory for say 10 elements. So suppose this is your array allocated now, created here with 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will have its own indexes also. Now the starting address of the array. Starting address of the array is stored in this pointer. Address of array, isn't it? Now when the function, then you after that you stored values also using scanf. So you have some values also stored in here. Value, 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 and so on. All the values stored in the array. Okay. Now when you do return, when the function is going to be over, there is a local variable pointer going to get destroyed. So but we don't want it to be destroyed, because in this we have stored the address of the array in which we have values. So what we do is we give a statement here, return statement, return ptr. ptr won't get returned. In fact, the contents of ptr will get returned. The contents of ptr will get returned and will get stored somewhere. What is returned in the main, it comes back to main. So here it will get stored somewhere. So you store it in array. Now this array will store the starting address of the array. This function will be over. The pointer will be destroyed. Everything in the function, even the traces of the function, will be destroyed. You won't have anything, as if this function was never called. Now the main function, look at the main function now. The main function now have direct access to this array. Okay, this is what is going to happen here. Here you will return the PTR in which you have the address of the array. What is the data type of PTR? Integer pointer. So you have to specify that you are going to return integer pointer. Also in the prototype, you will specify that you are going to return integer pointer. Oh, now you realized. Now you realize that you are going to return the integer pointer and not integer. So this in the beginning you had no idea, I had no idea, we had no idea. Suddenly there is a realization that we are going to return integer pointer. This function is over. Come back to main. Now we are going to call the display function. Display array function. This one. Let's write the display array function. Here we are. Display array. So we know that we are going to have integer return type because we have no other idea. Display array. So let's start displaying array and remove all the stuff, all the other stuff. Okay. To display the array we need a for loop which goes from 0 to size of the array. Int I loop variable which will go from I to size of array s. What is s? S was a local variable in get array function. Because it was a local variable in get array function, its scope and lifetime was limited only to the get array. It can't be used in display array. So a very obvious option is to make it global so that everybody can share it. But then when you make it global, then the security compromised in a way that you can have another variable with the same name in some other file and there could be conflict of identifiers. If you don't want that conflict of identifiers to happen in the shared space, then you declare this variable as extern int size. When you declare a variable extern int size, you actually don't declare it. You define that there is going to be a variable of type integer named size. This is definition, this is not declaration. No memory is allocated. Then when you come to main, in the global space in main, you can declare here it as a global variable int size. Now the size is known as a global variable, which is of course in turn extern. Because it is extern, it will be externally shared in all other files and you will not be able to have any other variable with the same name. So the conflict of identifiers will not happen. Okay. So in the get array function, where you have used size for the first time, you had declared a local variable int s. Remove it because you already have a global variable, extern variable size that will take value here. See, pointer is the beginning of the array, but does that pointer know what is the end of array? So we have to pass size. We have to have the display function also know the size. Replace s with, no, it will not give because there are no bound checking on arrays. Yeah. So here it is. Now we know what is size. So come back to display function now. The display array function will know that it has to go till size and the size has a valid value. Okay. Now you have to display. So it's not a scanf, it is a printf, where you will display two things. First you will display the index with a width of 2 characters, arrow operator. Then you display the integer value, add that index with the width of 3 characters. So the values will be displayed from the name of the array. What is the name of the array, by the way? Or the pointer to the array? We don't know, because the address of the array is right now with the main function. Get arrays function anyway, history, it's gone. So when you call the display function here, display array, we realized just now that display needs the address of array. So you pass this ARR pointer as argument. This pointer contains address of array. Go and take it. Because you are alone in the batch, so I am cooperating with you. नहीं तो सारे डिस्टर्ब होते. Just go and collect it. So we just now realized that display needs the address of the array. So therefore we passed address of the array which was stored in the array pointer. We passed it as an argument, and then the control jumps to display function. Now in this function we take a pointer, say ptr, and in this pointer we'll have address of array. Now notice, when we pass this pointer as an argument, the pointer was not passed as argument. The contents of pointer were passed as argument and copied in a new pointer called ptr. This pointer is called formal argument, in which the incoming address is stored. Now the display function also have access to the array, and the display function can print the array. So we realized that here we have to pass the array as argument, and in the function we will display function we will capture int star ptr, starting address of the array, and in the prototype also we have to modify that the display function is capturing integer pointer as argument. And now you can display using ptr plus I, and all the array elements will be displayed. The display function need not return the ptr, as the return value of display is not needed, because when the display function will finish displaying everything, after that the display function will be over and destroyed. Even the formal argument pointer will be destroyed. Nothing needs to be preserved, because the starting address of the array is already with the main function, and main function have access to the array. Okay, so this is it. We are left. This is what we are left with, and finally the program will end. Main function will end. Now this was easy till now. What you have to do is, every time you write a program from today, you will have your program split in multiple functions in multiple files. Okay, so later on you will have so many files, no? Like you see in batch 153, we just started the project and we already have so many files. When you will start your C project, you will have approximately between 90 to 100 files, and the code will go beyond more than 10,000 lines. Okay, so it is not possible for us to compile all the files. It is not feasible to compile all the files all the time. So a compilation build utility we have to create called Makefile. Did I tell you about Makefile earlier? So see this carefully. Capital M. Start with capital M. This is a shell script. We will be using bin bash shell to create this Makefile. This Makefile will compile so many C programs together and ultimately create a program called array. Instead of a.out, the compiled program will have name array. Okay, this is target. This target will be created from dependencies. So the Makefile will have this architecture, the Makefile architecture. it will have a target. Like in our case, target is array. This target will be created from dependencies. Okay, and dependencies will be resolved using rules. Okay, like this. Target is array. Dependencies is set of object files like main.o, which will be created from main.c, like get array.o, which will be created from get array.c, like display array.o, which will be created from display array.c. The rules are, when these object files are created, then you will compile these object files and give it an optional name called array. All the object files will be merged together in one executable file called array. And this is how you will create your target. Okay, so we can say here that the dependencies are set of object files okay, and the rules are utilities and tools to compile and link. Okay, I'll show you. Now the question comes, how are you going to create main.o? Means resolve the dependencies like this. Sub-target main.o will be created from 3 files. One is main.c. In main.c you have included headers.h and you have also included declarations.h. So this is local dependency of the main.o. The rule that you will apply is compile main.c, compile only, don't link main.c. So it will create main.o. Similarly for get array. The get array.c, get array.o will be created from dependencies get array.c, headers.h and declaration.h by using these rules. Similarly, display array. It doesn't matter, the order doesn't matter here. Okay, like this you resolve the dependencies, apply rules and create all the object files. And now all the 3 object files are created, so the dependencies are resolved. So you apply the final rule to create the target array and the target will be created here. Okay, so this is how the Makefile is created. Now to run your program, ensure that all the programs are saved and you have the Makefile ready. Give the command make, make, enter. Now make starts. Make compiles your program main.c separately. It's bug free. Make compiles get array.c. In this it finds I undeclared. So you go to that particular function get array.c and declare I, the loop variable. Make again. When you do make again, here, so it compiles get array.c. See, it did not compile the main.c because the main.c was already compiled, so there is no need to recompile it. This is the biggest advantage that you draw that you don't recompile the already compiled programs. Now you're compiling getArray.c, but in this function you had s undeclared in line number 21. This is not s, it is actually size. Make. Now make starts. Now getArray.c is also compiled successfully. C did not compile the main.c because it was already compiled. Now it went to displayArray function, and displayArray function had some bug in line number 7 associated with printf. Let's see. Line number 7 have some bug. Int I, missing semicolon. Make. Now it says undefined reference to exit function. Because we have used the exit function in our program, we have written the exit function also, but we did not include it in Makefile. We forgot. Let's do it. Exit function.o dependency, exit function in the rules, and the local rule for exit function. You can keep it anywhere, order does not matter. When you are giving this, order matters. Exit function was used in getArray, so you should put it here and not at the end. But the order of resolving these dependencies, the order does not matter. Let's try again. Close. Make. Oh, it's done. See, only the exit function is compiled, nothing else, because the rest of the things were already compiled. If I open a program, okay, suppose I open this program. In display, I add, do some modification, and then I try to make again. See, only display array, the function that got modified, is the only function that got compiled, and the whole program project did not compile. And the target file array is created. Let's run array. There it is. Enter array size, say 10. Enter array elements. There is the array. Okay. No, something is wrong. We are not displaying the values properly. Okay. A small stupid mistake. We did not give value for the index. See what the Makefile will compile. Only, oh sorry, we have to compile first. Build. Only the display array got compiled because that is the only function we modified. Run. Size 10 elements. And everything is displayed properly. Okay, so this is how we will program, and this will be our programming style always. Okay. Now you see, unnecessarily so many object files are kept here. You don't need object files. You're never going to work with that. You need C files, header files, and you need the target file array, isn't it? So let's go to the Makefile and put in a label there that will remove all the clutter. In the Makefile, you create a macro, label called clean, and in clean you remove all the object files. Now to use that clean label, you use make clean. Only the clean label command rm*.o executed and all the object files are gone. If I do make clean again, then it gives you no such file error there. You don't want this error to be displayed. So you precede this with an ampersand sign. Now see what happens. It is not showing the command, okay, though it is displaying the error, but internally the error is displayed, uh, ignored. Or you can also try to proceed with the hyphen. There you see, ignored, not ampersand, hyphen. So what happens is, error was generated that the files that you're trying to delete are not available. Okay, this error got generated but ignored. Okay, this is important to be put in the Makefile. So therefore, we use ampersand hyphen. This is Makefile syntax. Okay. In the Makefile, okay, done. So this is how it works. Okay, and we must make it sure that no, we are not creating array file. We are creating array data structure which occupies space in memory. Okay, it occupies space in memory. Because it occupies space in memory, the array occupies space in memory. The file is something that occupies space in the secondary storage. Okay, the array. No. When you are destroying the .o files, see, we have destroyed all the .o files. The array file, which was the executable file, did not get destroyed. It is there. It is very much there. Okay. No need to have extension. Actually, Linux does not work on extensions. Linux works on file information. Stat command. It works on type of file. Okay. Linux doesn't work on extensions, but still we have given extension .c because GCC wanted the file to have .c extension. Linux doesn't work on extensions. Okay. So Linux works on type of file. It says it's a regular file. These many blocks occupied of 4096 bytes each. This file have execute permission. From here, Linux understands, okay, this is an executable file. Owner is root, group ID is also root. Access, modify, change, birth information given. Okay, this is what Linux looks at. Okay, so this is the first time we have discussed modular programming split into multiple files, and I introduced you to the Makefiles also. Remember to have Makefiles. You have created one Makefile, you will create it once, then you copy it into every program that you create, and you must always have the Makefile handy, and you must always split your program into multiple functions in multiple files and use the utility called make. Don't compile your program using GCC. Okay, make is the only way. Even when you will compile make, you will need a Makefile, and right from the beginning you start learning Linux, you start learning C, you start learning shell scripting, high-end Makefile, everything together. Okay, so all these three things could be learned and only together. You can't have three things learning separately one by one. Okay, that is the reason that people put in a very good, honest and hard effort, but people are not able to master these things because they learn everything one by one. You know, you can't walk long by hop 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 by right leg, then hop 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 by left leg. You have to use both the legs together. Similarly, to master these things, you have to use all the three things together. Okay, that is what we do at mLogic. We take the right things together and take you forward. So because you are using all the things together, so you become very good in these things. Okay, so from today onwards, we will be using only pointer to arrays. We will be using only functions split into multiple files, and we will be using make files to compile our programs, however number of files are there. We'll never use GCC. Okay. Tomorrow again I'll pick up another example with you in which we'll have some bugs, and then we'll try to resolve those bugs using GDB. In turn, learn GDB. Okay. So I think your class, which was supposed to be on Wednesday, has been moved to Tuesday, because Wednesday we are conducting some extra classes. Every day we are conducting extra classes because Saturday Sunday we are